Have you ever really stopped to think about what happens to your food after you swallow it? I mean, it's not just getting mashed up, it's being completely taken apart and rebuilt on this incredible chemical journey. Right now, inside you, there's a hidden, high-tech factory working around the clock to turn your last meal into fuel. So let's take a look inside this amazing internal world.
So to get started, let's just talk about scale. Get this. Every single day, your body cooks up almost 7 liters of digestive juices. Now, to put that in perspective, that's more than 3 of those huge soda bottles. We're talking about highly specialized chemical cocktails, all created on demand. That sheer volume alone tells you just how intense this whole process really is.
So where does all this stuff come from? Well, before we actually follow the food, we need to meet the workers on the factory floor, the millions and millions of tiny secretory cells that line your digestive tract. These are the microscopic engines that produce every single drop of those 7 liters. And if you could zoom in, you'd see that each one of these cells is its own little factory. Seriously, it pulls in raw materials, things like proteins, water, salts, straight from your bloodstream. Inside, you've got these little cellular assembly lines and packaging departments building the final product. Whether it's an enzyme or mucus or acid, it's all put together, packaged up, and then shipped out into your digestive system. It's a perfect, self-contained little production unit, just repeated millions and millions of times. Okay, but how do these tiny factories even know when to turn on? Well, they're hooked into this really sophisticated command system. Sometimes it's a simple physical trigger, like food literally touching the wall of your gut. Other times, the gut's own local brain, and yes, it has one, a network called the enteric nervous system, sends out the order. And as we're about to see, even just thinking about a good meal can get the factory humming, all thanks to signals zipping down from your actual brain and a whole cascade of hormones. All right, let's follow the food. The journey officially kicks off in the mouth, where your meal gets its first chemical welcome, saliva. And this isn't just water, not by a long shot. It's a surprisingly complex fluid with 2 very different and very important jobs. You can think of saliva as a 2-part welcome committee. First, you've got this watery fluid, and it's packed with an enzyme that gets to work immediately breaking down starches. That's actually why a piece of bread starts to taste a little sweet if you chew it for a while. The second part is mucus, which is this thicker fluid that lubricates every piece of food, making it possible to chew it up and swallow it safely. Without that, every single bite would be a real struggle. But saliva's job doesn't stop at digestion. It's also your mouth's first line of defense. It's constantly washing away bad bacteria. Plus, it's loaded with powerful antibacterial compounds and even antibodies, making it a crucial part of your immune system before food even gets to your stomach. And you know that feeling we've all had where your mouth waters? It's not just in your head. The sight, the smell, or even just the thought of a delicious meal sends these signals rocketing from your brain down these nerve pathways straight to your salivary glands. It's your body being brilliant and getting a head start on digestion before you've even taken a single bite. So once you swallow, the food travels down into a much, much harsher environment, the stomach. Think of it as this muscular, high-security holding tank filled with a powerful acid that's designed to liquefy solids and just annihilate any microbial invaders that hitched a ride. Now, the stomach wall isn't smooth. It's actually lined with millions of these deep pits, or glands. And inside, you find 2 key types of factory cells. Near the top, you have the cells that churn out that powerful acid. And then deeper down, there are different cells that make a crucial enzyme, one specifically designed to break down protein. So how in the world do these cells create something so incredibly corrosive without destroying themselves? It's just a fantastic bit of cellular engineering. The cell basically uses a high-energy pump to force hydrogen ions out into the stomach. This process creates hydrochloric acid that is about 1,000,000 times more acidic than your blood. It's an incredibly potent chemical manufactured safely inside the cell and only deployed when it's needed. Okay, here's the big question. If the stomach is so good at digesting protein, why doesn't it just digest itself? Well, the solution is genius. The cells don't release the active enzyme. Instead, they release this harmless, inactive version called pepsinogen. It's only when that pepsinogen hits the super acidic environment of the stomach that it flips on and becomes pepsin, the protein destroyer. It's a perfect biological safety switch.
And the stomach's acid production is timed perfectly, almost like a three-act play. The first 20% is the cephalic phase. That's just your brain getting the stomach ready because you thought about food. The main event, about 70%, is the gastric phase, which gets triggered when food actually arrives and stretches the stomach walls. And then a final 10% trickles out during the intestinal phase, just to make sure the job is done right. It's a beautifully regulated system.
After a few hours in that acid bath, the stomach has turned solid food into this thick, acidic slurry called chyme. Now, as this chyme gets squirted into the small intestine, it would cause some serious damage, but it is instantly met by this perfectly coordinated response from a whole new chemical team, the pancreas and the liver.
The pancreas is really the master chemist of this whole operation. It pumps out this potent cocktail of enzymes, and each one is tailored for a specific job. You've got trypsin to keep working on proteins, amylase to finish off the carbs, and lipase to start the attack on fats. It's basically a complete toolkit for deconstructing your meat.
But what about fats? They clump together in water, which makes them a really tough target for those enzymes. This is where bile comes in. Bile, which is made by the liver, acts exactly like dish soap on a greasy pan. It smashes up big globules of fat into millions of microscopic droplets. This is called emulsification. And what it does is give the fat-digesting enzymes this huge surface area to work on, letting them do their job way more efficiently.
So how is all this timed so perfectly? Well, the moment that acidic, fatty chyme enters the intestinal wall releases hormones into the blood. One hormone tells the pancreas to release an alkaline fluid to neutralize all that acid. A second hormone tells the pancreas to send in the digestive enzymes, and it signals the gallbladder to squeeze out the bile. It's like a perfect hormonal handshake, making sure everything arrives exactly when and where it's needed. And the body is just unbelievably efficient. Making bile takes a lot of energy, so it doesn't just get thrown away. Get this, about 94% of the bile salts are reabsorbed from the intestine, sent right back to the liver, and put to work all over again. This recycling loop is so good that a single bile salt molecule might make this trip up to 17 times while digesting just one fatty meal. That is an absolutely remarkable internal recycling program. This entire process is this delicate, intricate chemical ballet. So, what happens when a step is missed, or one of the performers falters? Understanding how the system works helps us understand some really common health problems. Remember that delicate balance we talked about between the acid and the protective mucus in the stomach? A peptic ulcer is what happens when that defense is breached. And a lot of the time, the culprit is a specific bacterium, H. pylori, that can literally eat away at that protective mucus layer. This lets the stomach's own powerful acid and enzymes start digesting the stomach wall itself, and that creates a really painful ulcer. And what about bile? Its chemical recipe has to be absolutely perfect to keep everything dissolved. If that balance gets thrown off, and it's often because of too much cholesterol, that cholesterol can start to crystallize, kind of like sugar forming rock candy. And over time, these crystals can grow into painful gallstones, which can block the flow of bile and cause some really serious problems. So from just a simple thought about food, all the way to the final absorption of nutrients, the journey of a meal is this unbelievably complex and beautifully coordinated chemical ballet. Your body does all of this without you even having to think about it every single day. It just makes you wonder, what other hidden marvels of engineering are happening inside all of us, right at this very moment?